All right, more. All right, I had a brain fart there. I had no idea what I was saying, but here we go. We are going to be solving more quadratic equations by factoring. Well, right now we're just working on factoring. We talked about GCF. That's the first thing you always look for is the GCF. Then difference of squares. That's the second one. You look for the difference of squares. And last but not least, then the third step is then you use the AC method. There's two forms of it. There's the easy and hard. And then the last step is factor by grouping. Right now we have covered factoring by using GCF and doing the AC easy method. And we also did the GCF and the AC easy method. We had those two combined as well. What we're going to be working on today is difference of squares. All right. All right, difference of two squares. Well, first of all, you have to recognize, here's the basic formula. In other words, the first term is a perfect square. Second term is a perfect square. And then the middle has to be difference. So it has to have those three key aspects. If it does, then that means I can factor it into that form. All right, so you have to ask yourself, looking at the first term, look at the coefficient. Is 9 a perfect square? What number times itself twice gives me 9? Well, that's 3 times 3. X squared, well, since it's a square here, that means that's a perfect, that's x times x. It is a difference. And 25, well, that's 5 times 5. So it satisfies all three parts. So therefore, this is factorable. It's important that you do this, even though it seems kind of stupid, but you'll see why in a minute. If you do it, it makes it a lot easier. So since this is factorable, I can pull it apart. So now you're going to take 3x. So one set of 3x goes here, the other one goes here. And you got a 5 and the other 5. And then you notice here in the formula it says one's negative, one's positive. So make one negative, one positive. It doesn't matter because it ends up being the same thing. So that is the difference of squares. The key to this is figuring it out. Is it difference of squares? All right? Because when you're factoring using this method, using these steps, if you notice, excuse me, how many terms is that? It's only 2 terms. So I can't use the AC method, whether it's easy or hard. I can't use it because there's only 2 terms. It has to be 3 terms in order to use this method. Factor by grouping, you need to have 4 terms. So all right, the difference of squares is the only one that you can use if you have 2 terms. Well, I have 2 terms. All right, so if this is factorable, it has to be difference of 2 squares. If it isn't, then it's not factorable. All right, so we're going to be looking at ones that are factorable. That way you can practice this technique. Let's go on to the next one. All right, is this difference of squares? Okay, part 1, that's 7 times 7, and that's a times a. What about 1? Is 1 a perfect square? What number times it by itself twice gives me 1? Well, that's 1 times 1. And that is a difference. So that is difference of squares. Right? 7a goes into 1, 7a goes into the other, a 1 here and a 1 there, and you make one positive and make one negative. And you're done. Next one. All right, now this seems a little bit more, well, it's different. We haven't seen this one yet. Well, what can I multiply by itself? Well, first of all, that's the same thing as saying a squared times a squared. And that's b squared times b squared. Even though we haven't covered the laws of exponents, when you see a 4 here and a 4 here, it is difference of squares, right? And this is a difference. All right, so that's factorable. So that means we can go on. So one a squared go there, other one goes there. B squared goes here, another one goes here. And you make one positive, make one negative. Now, the reason why we picked this example is I want you to show you that even though once we factor it, we can end up still having to factor some more. Well, this isn't difference of squares. It's a sum here. It's a plus. So that means this part right here is finished. But if you notice here, this is still difference of squares. Because this right here is A times A. This is B times B. And it's a difference. So that means I can factor that even more. So one of the A's goes here, other A goes here, one of the B's goes here, and the other B goes there. Make one positive, make one negative. Whoops, sorry. Make one negative, and there we go. Now we are finished because nothing else, these are sums, so that can't be factorable as difference, but these aren't squares, so we're done. All right, let's look at this one. There's another difference of squares. This is a squared and a squared. This is 4 times 4. And it's a difference. So when the a squares go here, another one goes here. 4 and a 4. Make one positive, make one negative. This one is done. It cannot go any further because it's a sum. I don't care what these are. It's a plus. It can't go any further. Here, this is a times a, 2 times 2, and a difference, or minus, or negative, whatever how you look at it. So that means I can factor it again. A, 2, 2, because here the 2, 2, A and an A. Make one positive, make one negative. So this isn't factorable, this isn't anymore, and this isn't either because even though it's a difference, these aren't squares. So therefore I am done. So when you have difference of squares, when you factor, doesn't necessarily mean you're finished. You have to look at what you have, see if you're going more.
This is James Crawford. Please call 2501.
2501. I have no idea what that's for. Let's continue on. Now I'm introducing GCF again. So we always got to do that first. All right, so that means, let's see, we got 327. Both are divisible by 3. Nothing's common in those, so there's my GCF of 3. So I have 3. No variables are in common, so I don't have to worry about that. So I'll take that out, so that becomes 1x squared minus 9. Okay. Now this is done, so we look at, now we can continue on because this right here is difference of squares. This is x times x, this is 3 times 3. So x, 3, 3. Make one positive, make one negative. And you notice here that's a sum, so that's done. These aren't squares, so that is completely factored. All right, so in this one, we had a GCF first, because that's always the first step. Then there's 2 terms, so that means it's difference of squares, which it is, and then we factored it, and then we're finished. Let's do one more. All right, GCF. All right, what can go into 50 and 72? I have no idea. So let's try 2. 2 goes into 50, 25. 2 goes into 72, 36. I think that's it. There's nothing else in common in those two. So my GCF is 2. A is not common in both, so I don't have to worry about that. But B is common in both. This is to the first power. This is to the first power. So that means I'm taking out B, and the lowest number, lowest exponent is 1. So when I do that, I get 25a squared. 1 minus 1, so the b's are gone. Minus 36, b's are gone. All right, so 2b, and now we continue on factoring. 2 terms, difference of squares. It's a difference. This is 5 times 5, a times a, and 6 times 6. So 5a and a 5a, a 6 and a 6. Make one positive, make one negative. And we are completely factored.